My name is Andrew Dunn, and for this presentation I chose to do Experiment 10, Thermochemistry Pizza Reaction. The purpose of this experiment was to look at the concept of thermochemistry and the heat change involved in the chemical reaction. Thermochemistry can be defined as the measure of heat energy and the changes of that heat and the energy throughout the chemical equation. Heat released throughout a chemical equation is classified as an exothermic reaction. The opposite would be heat absorbed, which would be classified as an endothermic reaction. A quick outline of the presentation today will be, the first thing we'll go over is the experimental, which is a brief outline of the steps involved in the experiment. Next would be the results, I included some tables and my calculations and the numbers that I found throughout the experiment. Some sample calculations of problems 1 through 3, and finally the discussion questions. First up is the experimental. First thing we did in the experiment was to set up the coffee cup calorimeter. This was done by taking 2 styrofoam coffee cups and placing them on the magnetic stir plate. A magnetic stir rod was put inside the coffee cups to help mix the solutions. Next, we set aside separate labeled beakers with the different volumes of NaOH and the HCl. The NaOH and the HCl was added and heated. A thermometer was used inside the coffee cup to measure the heat. Temperatures were recorded throughout the 5 trials. An initial temperature reading was taken along with additional temperature readings all the way up until the heat stopped rising. The calorimeter was then rinsed with cold water, and this was repeated for the 4 remaining steps. This is the data chart that was taken throughout the experiment of the numbers that I got. It shows the initial and the final temperature readings, the change in temperature, which can be found by taking the final temperature and subtracting the initial from it, and also the volumes of the NaOH and the HCl that were used. This graph shows problem number 1, which was basically to fill in the chart. The grams and the specific heat were held constant through all 5 equations, with the grams being 1 and the specific heat being 4.184. To find the T of solution, that was in the previous chart, which was found in your data. And the Q of solution was found by taking the grams multiplied by the specific heat and then multiplied by the T solution. The Q reaction could then be found by taking the opposite of the Q solution. And this would be a sample calculation of that. Problem number 2 was to determine the heat of reaction. The concentration was held constant through the first 4 equations, and in the 5th one, the moles was raised to 2.00. To determine the heat of reaction, you would take the Q reaction found in the previous equation and multiplying that by a constant of 1.995 moles, which was the same through all 5 calculations. And there's the sample calculation of that. Problem 3 asked you to do 2 separate things. The first was to find the average heat of reaction, which was done by adding up all 5 heats of reaction and dividing by 5 to get the average of negative 63.92. The second question was to find the percent error, which could be done by adding up, taking each of the 5 average heats of reaction, adding that to 55.9, dividing it by the heat of reaction, and multiplying by 100 to get your percent error. This was done for the first 3 trials. These are the discussion questions that went along with the experiment. First, 1A asks, explain why the average value for the Q reaction from trials 1 to 3 is different from that of trial 4. For that I answered, the average value for Q reaction for the first 3 trials varies from the value found in trial 4 because of the change in temperature. The final temperature was higher, resulting in the change in temperature to differ, and different temperatures affects the Q reaction throughout the experiment. 2B, or 1B, asks, explain why the average value for the heat of reaction from trials 1 to 3 is similar to that from trial 4, despite the fact that you started with twice the volume of each reactor. For this I answered, the average values for trials 1 through 3 were similar to trial 4, despite the difference in volume, because the volume does not affect the Q reaction, only the temperature does, like I explained in 1. Question 2 asks, explain why the average value for Q reactions from trials 1 through 3 is different, despite the fact that you started with the same volume for each reactor. As I said before, the same volume, it doesn't affect the volume because only temperature does. For 2B, it asks, explain why the average value for the heat of reaction from trials 1 to 3 is similar to that from 5. In that, I said trial 5 turned out to have similar average values for 1 through 3 because the concentration of HCl and NaOH was increased to 2.00 molar. These are my references.